who have been working on some interesting problems for almost 2 years now. But I'm here today not so much in that capacity. I also work with the Enterprise Ethereum Alliance to help understand how we can bring Ethereum technology into the larger banking institutions. And also with Hyperledger, which is much more broad than just Ethereum, but also about kind of blockchain and business and whatnot. But that's it. Let's get started. Okay. So, 2017 was interesting. These are 9 different cryptocurrencies, which I guess are probably too blurry for you to see, but I think you can see a general trajectory of what was happening in the marketplace over the last couple months. Great. I'm not here to talk about that either. Okay, so there's also been some security challenges over the last couple years, if you've been following public cryptocurrency. I'm not going to talk about those things either, but there's starting to be a lot more really great security talks when it comes to blockchain, smart contracts, cryptocurrencies, and this whole entire world. So, but I'm not here to talk about that. In fact, I'm pretty expressly not allowed to talk about that according to compliance. So we're going to talk about we're going to talk about other stuff. Blockchain. Ha 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 ha, why don't you just use a database? This is a picture that I keep behind my desk from Andrew Miller, who's an amazing cryptographer. And it just says, if you can't see it in the back, it says, do you need a blockchain? No. This is what I point to a lot of the times when people walk into my office with their next great blockchain idea, and I think it's good to keep us grounded. So there have been some great conversations on Twitter recently of people challenging, what do you need a blockchain for? What is blockchain? Why do we care? Why can't you just use a database? And 90% of the time we're right, or you're right, and that's okay. But when it comes to information security broadly, I think we could do a lot better job of getting engaged. And it's really easy to just dismiss stuff, kind of like saying, well, the cloud is just somebody else's computer. Well, the blockchain is just everybody's computer. But there's now an entire industry of figuring out how to secure cloud. So maybe we should pay a little more attention. So why can't you just use a database? Well, usually you can. And sometimes you really could, but there's human reasons, things like business coordination or regulatory requirements or people not getting along or disincentivization to collaborate that are reasons why these centralized solutions have not taken off. An example of this might be something in the finance world like trade registries. So if you have something that you'd like to pledge as collateral for a financing transaction, this could be anything from some money to an oil tanker, you'd like to make sure, the bank would like to make sure that you haven't pledged that same collateral more than one place, because then you're over-levered and only one entity can really repossess it, right? So in the event of default. Well, that sounds a lot like a prevention of double spend problem, which is the same thing that we have in a cryptocurrency system. So people have looked at, could you create some sort of decentralized trade registry? Because historically, centralized trade registries that cross global jurisdictions has simply failed to take off. There's no supranational enforcement. It's impossible to get people to want to collaborate, and there's really no incentive to do so. It disincentivizes participation, and actually is better if you don't tell people, because you don't want to pledge it, because then you can do the bad action, right? So in that case, people are looking at blockchain technology. But in other cases, centralized solutions do exist, but they're deeply inefficient or they have just outright failed the market, right? So when we talk about disintermediation that you hear a lot about in business now, or especially in banking, that's really about inefficiencies and wanting to go straight from from offerers to issuers or users to enterprises, and creating like peer-to-peer markets that aren't just person to person, but are more B2B. Great. But other times, think about centralized solutions that have perhaps not fared so well. Equifax. So if everybody gives their data to one centralized third party, we're creating centralized points of failure. Right? And if you look at how a regular blockchain works out in the public space, so something like Bitcoin or Ethereum, data is incredibly transparent and it's distributed everywhere, and that would probably never work for business. That's okay. Instead of, when people talk about enterprise blockchain, what they're talking about is figuring out a way to lay privacy on top of this stuff so that now you're actually creating or reducing the centralized points of failure and creating information boundaries around different organizations so that you're limiting the potential downside of information disclosure. That gets a lot more interesting. So yeah, businesses are really experimenting along this entire spectrum. In some cases, what are they talking about? Is it a distributed database? Yes, and that's okay. If there's a single system administrator that can pull the plug, then it's probably a distributed database. But when you talk about different organizations getting together and creating some sort of consortium, where there's really no one person to call to shut the thing down, it's not exactly a distributed database anymore. And that introduces a lot of new challenges. So, let's see. Problems like, besides the data privacy, how do you handle compliance, or what if there is a data disclosure event? What is the governance model? Who decides who can come in and participate in this thing if it's not just broadly open and public? If you're a bad actor, or you say, we're going to kick bad actors out of the system, we're going to rely on legal recourse, we want to fold this in with existing regulatory schemas. What defines a bad actor? Is that based on terms of use? How do you actually hold a transaction for dispute resolution? It's a completely different problem set than what people are talking about when you talk about trustless, censorship-resistant payments that are Bitcoin or other systems. And that's okay. It doesn't mean that one is good and one is bad. They're trying to solve different problems, and you end up with just a different underlying technology stack. So if you understand Bitcoin, and then you say, why would we use this for business? That's stupid, just use a database. We're kind of just missing the point of what mutualized infrastructure could mean in the future. So blockchain, quote unquote, has brought, quote unquote, new ideas to the C-suite. Here are a couple of them. I have been asked to explain every single one of these things to people with a C in front of their title over the last 2 years. It is somewhat terrifying. But that's okay, because much like regular people on the street screaming, I love crypto, it means that, when they have no idea what cryptography is, that's okay. It means that there's interest in these topics, and we actually have an opportunity to bring people in that are interested in our work that we've been doing tirelessly and thanklessly for decades, and for some reason we want to just yell at them and tell them to get out and they don't get it. So maybe we could do a better job. So let's talk about one of these things in practice here, zero-knowledge proofs. This is an area where my team is doing some interesting work and research, so hopefully as a case study it'll help make this all make sense. So zero-knowledge proofs, if you're not familiar, are a way to prove something to a third party without disclosing the original inputs, right? So ZK snarks, which is a specific type of implementation of a zero-knowledge proof, allow verification of the correctness of computations without having to execute them or possibly even knowing what was executed. So it's kind of bananas, right? But basically what you want to take away from this is that there's like a whole lot of math, like so much math happening here, right? Number theory, right? So you need to understand, in order to understand ZK snarks, and I would say that in the whole world there's probably, like, we're talking about a dozen people who truly understand these things at deep, deep depth. And luckily I probably get to work with like a quarter of those people regularly. But you're talking about how to use arithmetic circuits. We're using homomorphic hiding and encryption. You're talking about expressing things as polynomials and then figuring out ways to make statements about the curves that those polynomials generate without actually disclosing the exponents that create the polynomials, right? Lots and lots and lots of math. We would not want, and I'll explain in a second, how we do not want Java developers at banks to have to express business processes all as polynomials. But that's not the point. The point is, it works, but it's what's been lovingly referred to as moon math. Okay, so in practice, what does ZK snarks mean? Well, has anybody here heard of crypto kitties out in the... Yeah, all right, lots of love for crypto kitties. Okay, so crypto kitties on the public Ethereum blockchain, these are all cryptographically unique Pokemon, essentially. You can breed them, you can trade them, you can sell them. I think at the last count, the highest priced crypto kitty had traded for about $117,000. That's because everything is meaningless at this point in life. So, and that's okay. So CryptoKitties don't use ZK snarks right now, but if they did, what you could do is, if you were going to trade your ridiculously overpriced CryptoKitty to someone else, you could disclose a single trait that they have without letting them know what the entire kitty genome holds. So where might that pop up in other, more perhaps real-world situations? Well, let's talk about these business leaders who come into my office when I get to point at the no, don't use a blockchain sign. Some of the problems that they come in with they're real problems, right? So if somebody walks in and they say, listen, we're worried about fraudulent account opening. And we know that despite our best work at AML and KYC and everything else, occasionally a bad actor is able to open a bank account here. And we know that this happens at all other banks around the world. It's kind of a tragedy of the commons problem. We want to share that information, but we can't disclose it. First of all, there's regulatory reasons we can't disclose that. Second of all, we're not going to dump everybody in our database into some third-party database because that's ridiculous. And finally, there's reputational risk to people finding out that this has happened. So I'd love to get information from somebody else about what bad actors have done at their bank, but I don't want to share mine. It sounds a lot like the generalized problems with privacy, right? Like, I really love privacy for myself, I just don't want privacy for anybody else. So how do you approach that as a business problem? And then they say, can the blockchain fix this for me? Right? Because they've heard cryptography, they've heard privacy, they've heard data sharing, right? And in their head, this is a problem that maybe works on a blockchain. And you have two choices. You either tell them, like, no, a blockchain is really bad for that, and especially a public blockchain is exactly the opposite of what you're talking about. Or we think, actually, what they're talking about is something that sounds a lot like a zero-knowledge proof. And in a way, if you want to share the information or the outputs of a zero-knowledge proof amongst other parties who don't know or really trust each other that much or don't want to disclose things to each other, maybe what you want is something that looks like a decentralized smart contract that acts as a zero-knowledge black box that routes this kind of information that no one party has the ability to subvert. Right? So maybe there actually is an interesting use case there. And so that's where we can do a lot better job of listening to people's problems more than trying to solution them immediately or take the solutions that they come up with at face value, right? So when we talk about mutualized infrastructure, what does that mean then? If we're going to actually be looking at things like zero-knowledge proofs in an enterprise, it's kind of scary. So right now, we usually see a lot of trade-offs. This is kind of one of those, here's 3 things that we'd like, or possibly 6, I don't know, I was brainstorming. But choose two vertices. And traditionally, these are the trade-offs that we have when building enterprise infrastructure. But when we start thinking about how we could use distributed systems, and not just traditional distributed databases, but mutualized distributed information, can we start, if there was really robust privacy on top of that, could we start actually solving some of these problems in new and interesting ways? Maybe we could. All right, so now we're back to blockchain, but it sounds somewhat less stupid this time. So blockchain, robust, decentralized, privacy-supporting, mutualized infrastructure. So now we're going to talk about a specific instantiation of that. So this is not a product pitch, but this is the product that I work on for some of my day. It is open source, it's GPL, it's on GitHub, so if you're interested, please take a look. So Quorum is a fork of Ethereum. Ethereum is similar to Bitcoin, except instead of being a decentralized world currency, it's a decentralized world computer. It's essentially a distributed virtual machine wherein everyone executes every state transition collectively, so you all arrive at the same state of the world. It's really cool, but it has some challenges, namely the same ones that you'd find in a system like Bitcoin. So you have anonymous actors with completely visible transaction history. That's a problem for banking, right? So what we want to have is known participants, but with confidential data. And in order to do that, we've created something that kind of looks like this privacy sandwich, I guess. So, and if you're colorblind, the top 2 colors are orange and green, and you can't tell them apart, but it goes with the various headers here. So at the top, you have a zero-knowledge settlement layer, which I'll talk about in a second. In the middle, you have a shared blockchain, that's basically Ethereum. And in the bottom, you have what's called the Constellation Network, and that's a point-to-point messaging system that allows you to address smart contracts to another participant in the network in a way very, very similar to addressing a PGP email. Okay? So on the lower part of the sandwich there, the bottom bun, you are transmitting business logic, smart contracts, just like in Ethereum. But what you're doing is creating a separate private state trie that tracks the state transitions there completely privately. That's great. It was the first version of Quorum that was released. That was the entirety of the privacy solution. But it does require that you architect applications in specific ways to ensure that you would have mass conservation or prevent double spend, and that you couldn't potentially game the system. Everything was private. But having private trustless systems is an extremely non-trivial problem. So we were kind of there, but we realized that by adding this additional layer on top, which is a bunch of shielded tokens, they're tokens just like any other kind of ERC20 token in an Ethereum system, so not proof of work generated tokens, but you can create them and burn them at will, but they're completely shielded and they're kind of bean counters, right? So if we can have private business logic that exists off the blockchain, but is synchronized to the shared blockchain. So there's no funny business as to what's happening at that lower layer. But then on top of that, that private business logic can affect transfers of shielded tokens that have all of the really fun properties of a traditional cryptocurrency system. Now it's getting pretty powerful. So if you've heard of Zcash, Zcash is the existing real-world implementation of ZK snarks. It seeks to address some of the fungibility challenges of Bitcoin. Fungibility in banking is the concept that $1 in your pocket is as good as any other dollar in your pocket, and a $10 bill in your pocket is as good as 10 single dollar bills in somebody else's pocket. You might have heard that maybe every $100 bill in the US has some traces of cocaine on it. It's apparently a fact. I wouldn't know, a friend told me that. But you are not actually held responsible for that. The interesting thing about a radically transparent system like Bitcoin is that if it's entirely traceable and it's anonymous until it's not anonymous. So the more that individual wallets become de-anonymized and the more that regular people are starting to use Bitcoin and want to integrate it into traditional systems and open Coinbase accounts and actually pay their taxes on it, the smaller percentage of that system remains kind of away from the regular way settlement, right? So you end up with a de-anonymized system. And if you have visible transactions but also visible participants, now you just have Twitter for your bank account. So that's where Zcash came in. But we said, well, we don't exactly want to use Zcash. We have this other challenge. So ZSL, the zero knowledge settlement layer, all those tokens in the sandwich I was showing previously, are to Zcash in the same way that blockchain is to Bitcoin, right? So JPMorgan, not trading Zcash. Quorum uses zero knowledge technology. Make sense? Okay, great. So let's say that this actually existed at scale or was being used in production. Information security could start to look very different. Traditionally, we have thought about securing networks in a perimeter security model. Maybe you're lucky and you're part of an organization that says, imagine everything is already owned, how do we limit data disclosure? Maybe, that's on a good day, right? But in general, everything has been about keeping people out and assuming that if you're within the walls, you're safe. And imagining a system like this operating not just in between untrusted participants, but even within an organization where everybody quote unquote trusts each other, you could start to imagine information security functioning in a very different way. You can also start to imagine very verifiable audit logging such that an organization doesn't have to trust itself. Such that if regulations change tomorrow and you have to disclose new data that you didn't have to disclose previously, you can prove that that data hasn't been manipulated since back then. Right? So different ways to think about it that aren't just about creating censorship-resistant payment systems. However, integrating this stuff with traditional enterprise systems is not well understood. Nobody has really done this. Despite the press releases, none of this stuff is in production at any kind of a scale that's more than, double-digit numbers moving a day, if that, right? And that's okay. A lot of it is a hype cycle right now, but you have to get the news out there. It's the race to innovate. But what we have is a very long road to figure out how to make it real in the meantime. So where I'm at now, I guess, is asking people, how do you get involved? And assuming that not everyone is going to be doing kind of first principles R&D on these systems, but that at some point this will be as kind of out there as just using cloud native systems, what would it look like, or what kind of questions do we have to answer to integrate these systems into the ones that we know and love today? So from a network security standpoint, if you have mutualized infrastructure, who is granting access? How are we handling onboarding and offboarding? How trusted are the other participants? Depending on your trust model, you can use different kinds of consensus mechanisms. If everything runs on enterprise hardware, maybe something like a traditional RAFD, Paxos-y kind of thing looks fine. If it's not, and you've got 1 million participants in some supply chain use case, well, your private permission blockchain starts to inherit a lot of the security challenges of a public chain. So maybe you start looking at different kind of DOS prevention mechanisms. that start to look a lot like either proof of work or cryptocurrency. So again, it's that spectrum, and it's really use case dependent. How do we integrate these things with existing network management tools? How do we create peer-to-peer networks using existing firewall rules? Anybody who's ever had to make, I think at JPM they're called Perimeter Infrastructure Risk Assessment, PIRA, review analysis requests, in order to open a single port on a firewall, can understand how creating dynamic peer-to-peer networks where nodes come on and drop off all the time could be a challenge, right? When it comes to AppSec, it's kind of a nightmare right now. We are reimagining all of the challenges of the 90s in brand new terrifying ways. But we could be doing better. And with better engagement from folks in this room and abroad in the space, we could be doing better a lot faster. So how do we integrate or build libraries for existing scanning tools? How can we make formal verification something that's not scary within an enterprise but is actually welcomed? Just because the language is considered exotic right now, does that mean that it's a bad thing? How do we work with our existing CISOs to get them to expand the sort of encryption suites that they're used to using to include something like LibSnark? Like, all these things have never been done. So it's a pretty great time to try to actually tackle something new. And also, so many conference circuit talks here. I mean, you could just do nothing but go talk about solving one of these problems for a year. So if you want to go like thought leader, you could thought leader all over this for like 2 years. So go for it. Okay, so organizations will need people who understand the security nuances between distributed databases, distributed ledgers, information blockchains, and actual crypto asset blockchains, all of which are different architectural things. That means that we need you. So never forget that actually all mentions of #crypto refer exclusively to Cryptocleidos, the plesiosaur reptile from the Middle Jurassic period of England. Thank you. I guess, how long do I know? Okay. Any questions, any thoughts? Yes, go ahead.
So, in an industry that still runs like COBOL and a lot of really old technology, what are you doing to try and make sure that whatever technologies you're using today, 20 years from now, aren't severe liability?
Sure. Okay, so the question was, for institutions that still use COBOL, what do you do to ensure that the choices we're making now are not a massive liability? That is a good question. A lot of this stuff is experimental, and a lot of the enterprise blockchains that you see, of which I could probably rattle off a different dozen or 24 of them, a lot of them probably won't exist in some time. So the race to production does people a disservice, right? But designing things collectively is a good thing. The embrace of open source technology has been a good thing, where, as one specific example of a concrete project, JPM is working with IC3, which is the Institute for Contracts and Cryptocurrencies, that does a lot of kind of low-level R&D research at Cornell University and elsewhere. And one of the problems that we're working with them on is about integration and the very, very long tail of how to sunset existing systems into a system like this. How can you give existing databases blockchain-y properties without having to transform your entire infrastructure? Maybe all people want is actually a database with strong signatures, and that would be enough. So there's no kind of future ball, right, or crystal ball right now that I can say this is exactly what the stack of the future is going to look like. And I have worked in this industry for, I guess, more than 15 years now, which is terrifying, I guess. And I have never fully sunsetted any system. So I guess the punt to that is probably COBOL will outlive us all. Some claps for that. Yeah, go ahead. In a blockchain arms race with whom? Oh, other file systems? Oh, financial services. Banking, computers, what? I think I have never seen such a willingness to collaborate within the financial industry. People understand that these things only work if other people are working on them. It's a completely network effect driven technology. So if you work on something like AI or machine learning, you can pick a specific product vertical or chatbots or whatever, and you can pick a product and you can A/B test something on your existing users. You don't have to ask anybody about it. You can see if there's an ROI. You can do whatever. When it comes to blockchain, you just can't do that. If you're not working with other people, the system just doesn't make sense. I think it's a massive catalyst for collaboration, but everybody, of course, kind of wants to be there first. And I would say, thankfully, like the ability, I never really imagined, I've worked at JPMorgan much longer than the blockchain team has been in existence. I never would have imagined that I would be in a C-suite explaining some of these concepts to them. So just the idea that people are interested shows that they see real business value in these problems.
All right. Please thank Amber. All right, guys. So guess what? We're only like 1 or 2 minutes behind. Who would have thought?